Hello class, today we are going to learn subtopic 2.4 in your textbook. We are still in chapter 2. Our topic today is isotopes and its uses. At the end of this lesson, you are able to deduce the meaning of isotope, calculate the relative atomic mass of isotope RAM, justify the usage of isotopes in various fields. So let us go through the meaning of isotope first. Figure 2.15 shows three types. There are three atoms of hydrogen element. All of these are hydrogen, 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 hydrogen. What makes them the same is the proton number. I hope you still remember. If you see a symbol like this, a small number on the top left and a small number on the below left, the top left is the nucleon number and the below one is the proton number. So let us look at isotope. Isotope has 1, 1, 1. They have the same proton number, but they have the different nucleon numbers. Look at this hydrogen. It has 1 nucleon number. This hydrogen has 2 nucleon numbers, and this hydrogen has 3 nucleon numbers. So when you see a condition like this, where the elements of the same atom of the element have same proton number but different nucleon numbers, those are called as isotope. Just like the twins, okay? Twins, you have the same father's name but you don't have the same name. You and your twins are different. Okay, so let us you have to generalize, okay, the meaning of isotope. Let us interpret the information given here. Look at the three types of isotope. Si is for silicon. Si here, Si. Look at their proton numbers, 14, 14, 14. All of their proton numbers are the same, but look at the nucleon number, 28, 29, and 30. Their nucleon numbers are not the same. So we call this situation as the silicon isotope. Look at magnesium. All of the magnesium, their proton numbers are the same, but their nucleon numbers 25, 24, 25, and 26. It's increasing by one digit, So this is the situation we call as magnesium isotopes. And last but not least, let us look at phosphorus. The proton numbers are 15, but the nucleon numbers are 31 and 32. So this situation, we call this as the isotopes of phosphorus, where the proton numbers are the same, but the nucleon numbers are not the same. So what is the meaning of isotope actually? The general meaning, isotopes are atoms of the same element. Atoms, same element, Si, Si, Si. They are atoms, they are not molecule, with the same number of protons. You see, 14, 14, 14, but different number of neutrons. Okay, we say neutron because we say neutron because we focus on neutron. We do not focus on the nucleon above. I hope you still remember. If you are required to find the nucleon and to find the neutron, you just have to minus it. 28 minus 14. So the neutron number for silicon is 14. For this silicon, the neutron number is 15, and for this one, the neutron number is 16. So what is isotope? Isotope is the atoms of the same element which have the same proton number but different neutron number. Okay, I hope you are clear with the definition there. So before we go to the calculation on how to calculate the RAM or relative atomic mass, I would like to show you a few uses of isotopes. So isotopes are widely used in various fields as listed. So let us look at this. You have to memorize this one, okay class? Medicine, isotope cobalt-60 and isotope iodine-131. Cobalt-60 is used to kill cancer cell without surgery, and also is used to sterilize surgical tools. Okay, mensterilize ataupun membersihkan alat pembedahan. Iodine-131, treatment of thyroid disorder such as cancer, hyperthyroidism or cancer. In agriculture field, isotope phosphorus-32 is used to study the plant metabolism. In nuclear field, isotope uranium-235 is used to generate electricity through nuclear power generator. In archaeology, this one is quite famous in exam, carbon-14 isotope is used to estimate the artifacts or the fossils age, like the dinosaurs bones age. Lead-210 is used to determine the age of sand and earth layers up to 8 years. In industry, hydrogen-3 is used as a detector to study sewage and liquid waste. And in engineering, isotope sodium-24 is used to detect leakage in underground pipes. Okay, I hope you understand that isotopes has a lot of uses di dalam kehidupan harian. Ingat cobalt-60 membunuh sel kanser, iodine-131 merawat kanser tiroid. Tiroid tu yang di leher. Agriculture, pertanian, fosforus-32 membantu mengkaji metabolisme tumbuhan. Nuklear, uranium-235 menjana elektrik. Arkeologi, carbon-14 ini famous menganggar usia fosil ataupun artifak. Contoh-contoh adalah tulang, pasu, tembikar dulu-dulu. Lead ataupun plumbum mengkaji untuk menentukan usia pasir ataupun lapisan-lapisan bumi. In dalam industri, hydrogen 3 detector, okay, detect mengesan sewage dan juga liquid waste, kumbahan. Engineering, sodium 24 mengesan kebocoran pipe bawah tanah. I translate that in bahasa Melayu for you, okay. Please use your QR code scanner and you can scan more uses of isotope in your textbook. Okay, so development in the field of science, specifically chemistry, has maximized the use of isotope in various field. Okay, sangat-sangat banyak sudahlah study di dalam science, especially chemistry, yang memaksimumkan penggunaan isotope dalam berbagai bidang. So isotope are used for sustainability of life. The use of isotope sebenarnya menyebabkan both positive and negative effect on the environment and society. You can read more in this QR code. So mari kita tengok how to count, okay? You are required to count the relative atomic mass of isotope. Mari kita tengok jadual ini, 2.4. This is the number of subatomic particles. Okay, cikgu harap kamu masih ingat apa itu subatomic particle. Ada 3A, yaitu pen, proton, neutron, elektron. P-E-N, pen. So, mari kita tengok isotope. Kan I said to you just now, isotope tu adalah atom-atom of the same element. Elemen sama lah ni, unsur yang sama, chlorine. Cuma why diorang digelar sebagai isotope? Because diorang punya neutron number lain. Okay, so kita tengok atomic standard representation, okay? I hope you still remember. Bila ada symbol like this is the symbol for chlorine. The upper number is the nucleon and the lower number is the proton. If you are required to find the neutron, just tolak saja. So 35 tolak 17 is 18. Number of neutron 18 nah. So kalau kamu diberi begini, this is isotope of chlorine. Nucleon is 37, proton is 17. Tolak dapatlah, tolak ini 2, dapatlah number of neutron 20. That is why kita katakan isotop tu adalah atom-atom unsur yang sama. Dia atom-atom banyaklah tapi tetap sama, klorin, 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 klorin. Contoh, okay, unsur yang sama dengan nombor proton yang sama, number proton same, but number of neutron tidak sama, 18, 20. Of course, number of electron sama dengan number of proton lah. Okay, so mari kita tengok how to count the relative atomic mass of isotope. Apa itu relative atomic mass? Ini juga. Okay, this is the relative atomic mass. So, cikgu ringkaskan di sini. This number yang up here, yang di atas ni, dikenali sebagai relative atomic mass ataupun dikenali sebagai nucleon number. Nucleon number. Nucleon number. You can find the RAM, okay, relative atomic mass in the periodic table of element. Let us look at the periodic table of element ini. See, kalau dalam jadual berkala unsur, relative atomic mass tu yang di bawah ini 7, 9, 1, 23, 24. So itu semua adalah relative atomic mass. So macam mana mau kira how to count that? Let us learn how to count the relative atomic mass today. Okay, so let us look at the calculation over here. Relative atomic mass punya formula adalah, look at this one. This one, the big E is called as total. Total the sum. Total of percentage of isotope, peratus isotope times the mass of isotope, bahagi divided by 100. Let us look at contoh soalan apa yang diberi dalam exam. Okay, chlorine consists of 2 isotope. Ada 2 isotope lah. Look at this. The natural abundance, memang soalan akan bagilah. Natural abundance is the percentage of isotope. Okay, kalau ada sebut natural abundance, maksudnya itulah percentage of isotope present in a natural sample of element. So in the soalan, it says here the natural abundance of this one, the first one is 75%, and then natural abundance for the second isotope is 25%. Calculate dia punya RAM, chlorine. RAM of chlorine. So if we see in the periodic table of element tadi, this is the RAM of chlorine. It's 35.5. How to count this one? How to count this one? Okay? How to count this one until we get 35.5? Okay, let us look at the formula again. Okay, the formula of RAM shows that total of percentage isotope darab dia punya mass. Okay, so let us look at this. Relative atomic mass of chlorine. Sepatutnya we get this one lah, sebab in our jadual PTE, periodic table of element, 35.5 kan. So let us see how to count this one. Okay, dia punya, okay, let us focus on the first one first. According to the formula, it's the percentage darab dengan mass. Percentage dari mana dapat? The soalan already give you 75. Dia punya mass. How did you find the mass? Mass is the nucleon number. See? Nucleon number. Kasih turun saja nombor yang di atas. Tambah percentage of isotope for the second one. Kan kita mau cari untuk 2 isotope. So percentage of isotope untuk ini di mana? This one, 25. Soalan memang bagi. So 25 darab dengan mass kan. Look at this. Darab dengan mass. Percentage darab mass. Mass tu apa tadi? Mass is the is the nucleon number. Tu memang diberi. Dalam standard representation memang ada diberi tips lah. Bahagi 100 dapatlah 35.5. So that is just one example on how to count the RAM. Okay, cikgu tunjukkan balik RAM tu apa. Di dalam periodic table of element, semua elemen semua elemen ada RAM. Nina, nombor kecil di bawah. Nombor kecil yang di atas tu proton number. So, macam mana mau kira yang di bawah ni? Tengok dia punya formula yang tadi itulah. Okay, jumlah percentage of isotope darab dengan dia punya mass. Okay, bahagi 100. So let us look at the chapter 2 balik. I think that's all that you need to know for now about isotope. I hope you are clear with this one, and I want all of you to complete test yourself 2.4 as the conclusion for today's lesson. Thank you very much, class.